Today we're going to talk about quadratic application number 2. A model rocket is launched from ground level. At t seconds after it's launched, it is h meters above the ground. So over here you see where I kind of drew a little picture because they gave us this formula, h of t equals negative 4.9 t squared plus 68.6 t. Seeing this 2 again, I know this is a quadratic, and I know when you launch anything, it's going to have a maximum point here, and then it's going to come down, and it's going to hit the ground. And life is in quadrant 1. Then I want to label the axes. I don't care about the rest. I know that time is the independent because it says h of t. That means the height at a certain time. So the time depends on the height. The height depends on the time. So the time is my x-axis, and they told us it's in seconds. The height, they said, was in meters. So I can kind of label my picture. The rocket is going to launch, come up to the top, and come down and hit the ground. We have to answer 3 questions. When is the rocket at maximum height? So we're going to find out when that happens. So we're going to solve for time. The word maximum should make you think. You say, oh yeah, Mrs. Pond always said that we're going to use our axis of symmetry for that. So I'm going to kind of make note of that. How high does it reach? So this is, we're looking for my height in this case. And here is how long does it take to reach the ground? So again, you're looking at time again. Alright, so let's go through and do each one. And I know you have a slide at the bottom where you can fill all this in. So I'm going to start doing the work here. So first of all, we want to know when it's at its max height. And this is a parabola that opens downward, so it has maximum problems. I'm going to put down the axis of symmetry. And so I go here, this is my A, this is my B, and so it's going to be negative B over 2 times negative 4.9. And when I put that in my calculator, I get 7. And we got to label it 7 seconds because that is when, and let's label our picture as we go along, at 7 seconds is when it reaches its max height. So you've just answered the A. Okay? Now B asks, how high does it go? Well, if I know it's 7 seconds, let's look at this picture again. If I know it's 7 seconds, right here, this is my axis of symmetry that we just found. If I know it's 7 seconds, and I didn't mean to do that. If I know at 7 seconds that it's going to reach its max height, if I plug it into the formula, because this formula says the height at whatever seconds, if I put the 7 right in there, then I can find how high it goes at that time. So let's do it. So I'm going to do the height at 7 seconds is going to be negative 4.9, 7 squared plus 68.6 times 7. Okay. Now if I plug that in my calculator, I get the height to be 240.1 meters. So now let's go back and label our picture. This is 240.1, which is really the point, 7, 240.1 on the graph, meaning at 7 seconds I've reached a height of 240.1. Now the third one is how long does it take to hit the ground? Now if it hits the ground, that means my height is 0, so I'm going to take my formula, which we can't see anymore, but we're going to put that equal to 0. So I have negative 4.9 t squared plus 68.6 t, that's our formula that shows above, and put it equal to 0. Now what I would suggest that you do here is we've got some decimals going on here, so I would actually do the quadratic formula here. So I'm going to do the work over here. So I know you have a slide below, but I'm going to do it on here. So I'm going to do A is going to be negative 4.9, B is 68.6, D is, C, I skipped right over, I'm thinking ahead, C is going to be 0, and my discriminant, or my D, or my B squared minus 4AC, comes out to be whatever this is, b squared minus 4ac. The other thing you can do, if you don't want to do the quadratic formula, is we can actually try factoring it. So that will work if you want to do it that way. If you want to do by factoring, this one lends itself nice. I can take out negative 4.9t out of here, factor it out, and when I do, I get t minus 14 equals 0. So this one kind of goes nice. Make my big T. So you can do it either way. I just wanted to show you how you'd set it up if you were going to do it the other way. So this one I got negative 4.9t equals 0. So time is 0 when it first hits the ground, which makes sense. And this I have t minus 14 equals 0. T equals 14. So these are the time. This is seconds and this is seconds. And if I go back up here and look at my picture, this would be 0 and this would be 14. I need to see this. Please don't just double the 7. The reason why it works in this case is because it's coming from ground level. And because it starts here and it's completely symmetrical, this will be the case. But just don't double it. I don't care if you check it that way. I need to see this work. Okay? The last thing I'm going to add to this, I'm going to add a D to this. So I know you have a blank screen, a blank slide underneath. We're going to do a D to this problem. And the question is, here's our formula, so we'll have it here. H of t equals negative 4.9 t squared plus 68.6 t. I want to know when the rocket is 200 meters above the ground. Okay? Now, if I were doing this question, I would look at it and say, okay, wait a minute, this has got to be something I know. And let's look at our picture. We know it goes up to 240, so we'll pretend this is 200 right here. You know this rocket's going to come up past 200 here, go up to 240, come back, it's going to hit 200 again, and then before it goes down. So somewhere in here before 7 seconds, and some here after 7 seconds, but before 14 seconds, it's going to be 200 meters above the ground. So we're looking at the height has to be 200 meters. So in this whole spot here, I'm going to put 200. I want to know when, so I want to know time when it reaches 200. So this is what we're going to do. We put 200 there, so I'm going to put negative 4.9 t squared plus 68.6 t equals 200. Now when you go to do these, most often you're going to use the quadratic formula. I did show you where you can actually factor this, but I know this one's not going to be as nice. And now I have to make it equal to 0, so I'm going to move the 200 over. So I have negative 4.9 t squared plus 68.6 t minus 200 equals 0. Stack and rack. A, B, C, D. A is negative 4.9. B is 68.6. C is negative 200. So when I do my D, my B squared minus 4AC, I get this lovely number, 785.96. So now my time, or x equals negative B plus or minus square root of 785.96 all over 2 times A. We're going to split it up. We're going to do the plus and the minus. Now you guys can put this in your calculator, and you're going to see that when we do the plus, we get 1.39 seconds, and the minus is 9.8607. And I feel pretty good about that, because didn't we say before that it had to hit before 7 seconds, so it's about 4, and then it hit later, so after 7. So that makes me feel good, because I know that we answered the question. So you could be asked this question too, not just if the height is 0, but any kind of height, when the height would be as it's moving along.